And we are live now.
Okay. A warm welcome to all and a very good afternoon. I am architect Tanya Verma, Associate Professor and Coordinator for 4th Year Advanced Building Construction, School of Art and Architecture, Sushant University. It gives me immense pleasure to introduce our young guest for today, Ms. Shriti, founder of Strawcture. It's a very peculiar name, and I think you'll be witnessing the entire journey of Shriti and how she has founded this venture, Strawcture. The first company in India to make home and school using compressed agri-fiber panels, which is 100% green building material. Her initiative stops crop stubble burning, which is leading cause of air pollution in North India. The panels are 100% green alternatives to gypsum, wood-based panels for external and internal built environment. She has a master's degree in construction management from New York University and B.Tech in civil engineering. She is also a TedX speaker. She has won a competition at United Nations Social Impact Challenge Award winner in August 2018 in New York City. The first pilot house built by Strawcture Eco won the Green Building Project Award by Smart City Expo in New Delhi in June 2019. Strawcture Eco is IIM Bangalore, Banastali University and SELCO Foundation. Shriti is also Ecum and Ecoing Green 2020 Fellow. I request Ms. Shriti to deliver her lecture and also request the participants to please post your questions in the Q&A box. And also, Shriti, I will take here the opportunity to share your entire journey because we have very young students along with us, and also you being an achiever, an innovator, I'll say. So please share your thoughts also. And students, I think you all should have lots of questions for Shriti. Over to you, Shriti.
Thank you. Hello, everyone. Because I can't see anybody, this would have been much more better doing this in class as a lecture. But so what we're going to do today is see value in waste. So I titled it Waste to Value. And thank you, Tanaya, for that intro. So as she said, I'm a civil engineer. Done my civil engineering from KITES, so from NCR, close to where you guys are put up and doing your schooling as well. And then I went for my master's for construction management because I had more interest to study. And I felt like, it's in a way it's that technical engineering business combination, but I didn't want it to be that engineer that has nothing to do with engineering after B school. So I thought I'll study construction management precisely, which is a niche. Even in India, there are very few colleges that have those courses. And that was a great way to blend in my technical background with business and then see what I can do with those two skill sets together. I started Strawcture Eco in June 2018, but I like to always say that the journey for me started in October 2017, which is when I planned to move back to India. So I was in New York, I did my master's, and like everybody else, I was very excited to work in New York, live that life. I was living it for a year, but I just constantly felt that I was not happy. And I can't put it in any other words, but really say that I wasn't passionate about what I was doing. The projects were similar. There wasn't much to learn, even though you would feel that would be the case in a very big construction firm in New York, but I came to realize that's not the case. And so it was an opportunity, not planned. A friend of mine told me that there's a fellowship happening back in India called State Bank of India Youth for India Fellowship, where what they do is they select 30 to 40 youth, people under the age of 30, between 20 to 30, select them and let them go and live for 1 full year in a completely immersive experience in a village where they don't tell you what to do. It's up to you to decide what you want to do with the community, not for the community. So the relationship is more collaborative. And you live there for a year, and post that, the fellowship gets over. There's no reporting, there's no project. So it's a very clean slate. It's up to you. So the way I see it, I took a very early sabbatical in my career in a year, and I just quit my job. And I told my boss at that point of time that I just want to move back to India for a year. At that point, I was actually planning to go back to the US because I had my H1. So for me, it was really a sabbatical for a year, experiencing something, coming back to the job that I was doing. So at that time, that was the plan. I come to India, I moved to a village which is called Pandhana. If you look it up on the map, it's this tiny village next to Khandwa, which is the bigger district in MP. It's a 3-hour bus journey from there. And I end up there. It's a tribal village essentially. So 96% of the community speaks a tribal language, which is called Kurku. They don't even speak Hindi. And this language is not a written language. So you can only learn by speaking. You cannot pick up a script and learn. So there it is. I end up landing from New York to that village in the month of October from 2 degrees to 35 degrees. So it was not just the temperature variation, but it was a complete cultural context that changed for me. And even though I am from India, I've lived my entire life here. Like many of you, I believe, we don't have that real context of rural India. It's mostly we sometimes go for a trip or trekking that we see it. And here I was supposed to live for a year. So it was a very interesting few first months. I just realized that the only way I could do this fellowship is by having a very clean slate, telling myself that whatever I've learned so far, I have to keep it aside and relearn. So it's not my engineering background, not my business, studies, accounting, marketing that's going to help me, but it's more about, your people skills. How do you empathize with people when you're talking, and especially when they're talking about real problems like poverty, water crisis? How do you navigate that while being there with them? And then hoping that maybe with my limited technical knowledge, I could somewhere make a difference for a year, which is again very short term to even say to make a difference, but at least contribute. So I went in with least expectations out of myself, but mostly looking to learn and listen, which I think is something which one should have, especially if you want to do something new, because you learn so much more by listening than talking. So if you're always looking for feedback, that's a great way to learn and improve your own skill sets. So the fellowship started. I did nothing around building materials or structure. As I said, I was just open to learn. So I realized that these women do farming, they do animal husbandry. So I learned how to take care of goats, chickens, cows, goat rearing, milk rearing, understanding how they are vaccinated, how to raise a 1-day-old chicken to 30 days when they become of a certain weight that they can be sold in the market. So it was a very different experience, but I was like, okay, whatever comes towards me, I'm going to learn. And that was only because I was willing to learn, is why the community was willing to share. So you can only get feedback when you're open to receiving feedback. You can't be defensive. When you say, okay, does my design look good? Did I do a good project? When you're defensive, when the faculty or a mentor gives you feedback, you should be, pardon my French, but like a sucker for feedback. And that's only how you improve. So I learned from them. They opened to listening and sharing. And so I started going to the farms with them because there was not much to do in the village, to be very honest. At 5 p.m., the village will shut down. People will go to sleep. And as a millennial, you don't go to bed at 5 p.m. So what do? There's no internet. There's no Netflix. So I used to read a lot. And in the morning, I used to wake up early and go with them to the farm and just see how they did agriculture. And that is where I had my first, again, unplanned experience of witnessing wheat straw and soya bean. These were the two crops that were abundantly grown. Those were the main two crops in that village. And when wheat harvesting was happening, that was the first time I saw that after they collected this wheat crop, there was this stubble lying on the ground, 2 to 2.5 inch long. And the next day, they just burnt it. Like literally, I saw it, what you see on the news during Diwali. I saw so many women just doing that. And that took me aback because I was like, oh, why are you burning it? And we started having a lot of conversations around it. Again, you have to be open. You can't be judgmental and say they're doing something wrong because you have zero context of why they are doing it. So I was open to listen and I realized that they are doing it because they have no choice. They're doing it because it's cheaper, it's free at that moment, as a cost, not long term, because that is something they do not have the privilege to think of long term. Because if you look long term, there is a cost. If you're burning your land and that ash and that carbon affects the micronutrients in the soil, but you cannot expect a farmer to have that long term viewpoint when he or she is really dependent on, sowing the land for the next crop in a week's time, or else they'll be behind. And that is their source of income, their only source of income. So I realized the ground realities of the problem. And that is where, again, I finally got an opportunity to think about my background, which is civil engineering, construction management. And I realized that the straw that we're talking about has a lot of potential. And the other reason why I saw the potential is because I lived in kacha houses for a while. So a lot of these families, as I said, are tribal, are from below poverty line. 96% of the population was below poverty line. So most of them had kacha houses, which was made of mud and straw. And I would witness every day, every 15th day in a month, women mixing the straw with mud, cow dung, and putting a plaster on the wall. And I kid you not, for the 3 months when there is summer in MP, which is May, June, July, the temperature every day was more than 40 degrees. And it was so much comfortable living in these houses than a proper concrete brick mortar house. So you didn't need it testing, you didn't need a lab to tell you as a layman, not even as an engineer, that there is some potential in this raw material. It's just that it is being used in a very raw and crude form. So that again caught my attention. Plus, so I see the problem, I see the value, both side by side in a very practical manner. And because I said I had a lot of time after 5 p.m. and not much to do, I started doing my research of knowing what is that is happening with this straw besides being burned and used as a fodder, which is its main alternative usage in any part of the world. So I did a lot of research and I came to know that there are few companies out there who are converting the straw into a building material in different ways, in different forms, with playing with its chemical composition, with different temperature, pressure variation. And that is where I felt that, okay, there is some value. Now there's a small amount of validation. So I'm saying it in a way, and I'm repeating few words because what I'm trying to get to you is that if you think of doing anything of your own, there's a life cycle to it. You have to first understand the problem, think of a solution, validate the solution at a micro level, which is usually called minimum viable product in the startup ecosystem, which means without spending too much money, prove your hypothesis, and then go and set up an organization or a company that can then scale it up. So for me, those first two steps of seeing the problem and the minimum viable product happened in the fellowship. And after that, I started the company when the fellowship got over. So immediately when the fellowship got over, I had to test my minimum viable product. I couldn't make the product myself so early. I didn't have the resources, the money, or a factory or land. So I reached out to these people in Europe who were doing it. And that is again one of the biggest learning in my life, that you have no idea what you can receive if you're willing to ask. So never feel shy of asking. Had I not that day written a LinkedIn message to someone sitting in Czech Republic, in Prague, in Europe, I would not be sitting here right now talking to you. So I write that LinkedIn message, they respond back in a week time. And that's how it started. I came to know about the organization. It's called Pandey, if you look them up on the internet. And they were working with wheat straw, the same straw that I witnessed as a problem. And they were compressing them into 2-inch thick plasterboard, similar to gypsum plasterboard, which is the main way of making walls and ceilings in Europe and North America. And they were confident that those panels had 90% more thermal insulating values than gypsum. And a country like Czech in Europe, which for most part of the year faces extreme cold weather, that was an important value that they were providing. So so they returned back my email. We have a couple of exchanges. And then I decide to go and meet them. So I had decent amount of saving from the fellowship because we got 15,000 rupees stipend. You don't have much to spend in a village. I could save easily 10,000 per month. And then I went and I met them. I saw the factory, which was 60 kilometers from Prague in an agriculture belt, and saw how the whole process of manufacturing happens. What is the reason that they are mixing? Because every straw is different. So though on a fundamental level, wood and straw are fibers, they're both natural fibers, they behave very differently with different chemicals, resins, temperature, and pressure. So I learned from them how they were dealing with this interesting raw material. And then I asked them that if they're willing, I would use my savings that I had from New York from my 1 year job. And I would like to buy a shipping container worth of this material to prove my viability of this back in India. Because India and Europe has a very different climatic condition. So whenever you're building or you're designing, you have to be responsive to the climatic conditions. So I felt that if this works great in a colder country, it has to be tested in a country like India with our hot and humid temperature in most parts and geographies. So they said yes. I paid for it. I came back to India. A month later, they sent the shipping container to a port in Gujarat. From there, it comes to Gorakhpur, which is my hometown in UP where I'm from. And that material comes to Gorakhpur. I use a space of land that my parents have that they gave me, and we build a house. We build a 350 square feet house using the straw panels that was imported from Europe, and we have a minimum viable product, which is a small home standing there. It's still there. So it's been 3 years now for that structure, and it is now one of our site offices, still functioning, and a small team of ours works from there, where most of the material is stored. So that's how it started. So once the building was there, I felt that there is genuine potential. And then I had the confidence to go in and set up a private limited company and call it an organization. And that's how the name came, Strawcture Eco, which was actually a name me and my mother came up with. We were playing with different words, and then we felt that structure. And since we are pushing this, so it was not about keeping it in the background, but going out there and really hitting people with this name first and saying to question it, and then tell them what's the story behind it. So that's how I started. And now I'm going to share my screen, which is a small presentation where what I've mostly done is I've created a case study for this raw material, not just from my point of view, from a global perspective. So also talking about other organizations in different part of the world who are working with this. I've put their hyperlink. So you can go read about them, see what they're doing, and then that how this waste being used creates value. So it's not just the environmental value, because unfortunately we're still living in the times where sustainability is a good to have feature, but it's still not a must to have feature. Nobody will just pay for sustainability or a green technology. So you have to offer more value besides that. So that is where the social and the economical value comes in, where we are saying that this material is not just green, but it's affordable. And I personally believe that on a fundamental level, affordability and sustainability goes together, because anything can only be sustainable if it's sourced from as local places as possible. And if you're using a local material versus a material that's being imported all the way from a different country, no matter what, at scale, you will be affordable. So it's a myth that people think that organic and sustainable technologies have to be expensive. They don't have to be expensive. They actually can be and should be affordable. So I'll go ahead and share my screen. Is my screen visible? Can just someone tell me that? Okay, great.
Yes, thank you.
Okay. So it's called Waste to Value. That's my email address, and the hyperlink is for the website of our company, Strawcture. So I'm going to start with numbers. So that was story, and a story is always better than a good spreadsheet, but it's the numbers that needs to back your gut feeling. So there I saw a problem, and then you look at the numbers behind that problem and the potential. So both problem and the solution. So in India and globally, the carbon footprint of the built environment, it's in two forms. There's embodied carbon footprint, and then there's operational carbon footprint, that I'm sure most of you as architecture students are aware that operational carbon footprint is the footprint generated because of the running of the building. So it's energy usage, and embodied is through the built material that goes into the structure. And that is the tricky carbon footprint, because it is decided at the design level, and if it is not questioned or reimagined at that level, and once it goes into the building, then it's locked forever. That carbon footprint can never be reduced. Versus in 5 years, you say, okay, I'm going to convert this hotel of mine and put some solar panel and start using, greener operational energy. So that's why it is so much more important as architecture students and architects in this industry to question the embodied carbon footprint of building material, because you really have the onus, responsibility, and the power to question it and to reimagine it before anybody else. And if that is done well at a design level, then the rest of the cycle will definitely be more green. Now, that in itself contributes 11% to the global carbon footprint, which is already the second most, and only after transportation. But by 2050, it's going to go up to 22%, and we will actually cross transportation. That means built environment and the embodied carbon footprint is going to generate more carbon than fuel in itself, coal as well. Now, secondly, the natural raw materials that are out there to build buildings, 60% of that raw material is consumed by built environment, which means that all the limited resources that are out there on the planet, any kind, so I'm not just talking about sand or soil, it's even water for that matter, all of this, 60% of that is consumed by built industry. So more than any other industry, we consume most of the limited natural resources that once depleted can never be replenished again. So those are the problems when it comes from the industry space. So that's the market. And now if we look at our solution, which is a straw, there's abundant amount of it available in the globe. So the usual thing that mentors tell you when you start a company is that how big is the problem that you're solving and the market for it. And that stats tell us how big the problem is. There's 0.6 billion metric ton of organic waste available globally. And this is data from 2012. So it has only grown more, if not. And India individually makes 500 million metric ton of that straw out of 0.6 billion ton, which is 1/12 of the global straw is just available in India. So we are not only sitting with a big pile of a problem, but we are in a position to actually exploit it and create a solution. And lastly, this organic waste, when decayed, generates greenhouse gases, which also contributes 5%. That means there's a potential to address 11 and 5, 16% of the greenhouse gas emission globally with a solution in the space in the industry that I and we and you work in, which is building industries. So the solution is that we have to start looking at this waste as a raw material, and we see nature as a source of this raw material to build environment. So it's an endless source. And the reason I say it's endless is because it's a regenerative raw material. So whether I and you like it or not, we need food to survive. And if there is food being grown, there's going to be a byproduct, which is these fibers for most of the staple crops like corn, maize, wheat, sugarcane, rice, cassava in Africa. So all of these major staple crops that are good, which are our source for food, will keep on being grown, and they're going to have a byproduct whether we like it or not. So it's regenerative by nature. So it's now an opportunity for us to tap into it, because if we don't, we still can't get rid of it. So that's that was the fundamental as to why we started what we're doing. So I witnessed personally a problem. I thought there was a solution. The problem and solution seemed at a huge scale that you can make a contribution and it might have an impact. And that's how Strawcture started. And our philosophy is that waste is only a waste if you waste it. So it's not just the two sources of waste that we are right now working with in our individual capacity, but any kind of waste. So it could be an organic waste, it could be plastic, it could be electronic. We want to see as an organization every waste as a potential raw material, and then do R&D and find ways to utilize it in the built environment space. Right now, we are working with two sources of raw material, which is sugarcane waste and paddy straw. These are the photos of photos of the product that we have, which is called biopanels. It's made out of sugarcane waste and paddy straw. We manufacture them starting at a thickness of 8 mm and going up to 40 mm, similar to the range that your ply or other plasterboard has. And we manufacture them in densities ranging from 700 kg per cubic meter up to 1100 kg per cubic meter. So you have a density that meets your ply MDF requirement, then a mid density, and then a high density so that it can be used in external application where it needs to be weatherproofed and moisture proof. You can laminate, plaster it, put tiles on it, do all kind of finishes possible. These are pictures of the raw material, and they look different because of the straw naturally in it, and also because we add a coloring agent, a coloring dye, to add to the aesthetics of the material. But if you look and feel the sample, it looks very natural, very raw and earthy. So what I'm going to start doing is I have 3 slides where I don't have any words, but because I say waste to value and reimagining our built environment, I'm going to use one of our projects that we have done as an example for different built spaces, so furniture, wall, ceiling, and then another example of an outer organization outside India which is doing something similar. So that what I'm saying is not just a local thing, but there's a global potential to this raw material and its application. The first picture that I have here is of a table or a stool, you can call, and this is made of pine needles. So we all know that wood is one of the most used raw material in the world, timber, as we call it, and pine wood is the most utilized source of timber in the world, especially in Europe. More than 500 million trees of pine wood are cut annually in Europe to meet the demand for timber. Now, when you are cutting pine wood down, it has another byproduct to it, which is pine needles. And 20 to 30% mass of pine wood is pine needles. And so Tamara Urjala is actually an architect, a designer, who thought of utilizing these pine wood and compressing them, doing R&D on it in terms of playing with different temperature, pressure, and turning it into 3 things. There's textile, there's composite materials like this tool, and then as a source of pulp for paper. So, and forest wool is one of his product catalog where he has used it and converted it into a furniture. And the second picture that you see is of our panels that I just showed you a photo of in samples that has been used to make this furniture by a furniture manufacturer in Delhi, who is now going forward and launching a complete product line with these green panels. You see the raw panels as the front, and the rest of the part of the furniture is also these panels that is laminated, very similar to ply. So once you put a laminate in veneer, you would not know what has gone inside it, whether it is wood or it is some other organic natural fiber in our case. But the idea is that by doing a mixed design like this, you're showing the potential, because often when you pitch this product to architects, the initial queries are, can I laminate it? Can I veneer? Can I paint? So this product answers both of those queries. The architect use it in a raw form and also laminated it. So this is one of the product out of the complete product range that they're launching next month. So that is one example of how we can reimagine our furniture by not using wood, which I think is the go-to material for anybody as an architect, designer, builder, contractor, as a PMC professional. That is our idea of what furniture looks like, and we have such a strong affinity to wood. But here what we are saying is that you can push your boundaries of imagining and imagine another source of fiber which is annually renewable, where you're not putting in efforts to grow it, it is being regenerated, and utilize it to make as good or better furniture that is out there. So you're not limiting your design capabilities, you're not compromising on functionality, but you are adding value to the material and still achieving these other 2 perspectives that are out there. So that's how we can reimagine our furniture. The second is a picture of how we can reimagine our ceilings. So the first picture that you see here is of an acoustic tile, and it is made of recycled cork. So there is 93% cork, which is basically a waste of wine bottles in Europe. And this is an organization based out of Portugal called Spinebeck. And they compressed this 93% of the cork waste with a binding resin and made them into different shape of low density fiber boards as acoustic tiles. Because when it comes to acoustics, your material has to be light in density. It should be able to absorb sound. It should be able to be cut in certain ways that the cutting, the grooving acts as a dissipator. So that's what they were able to achieve with this raw material. And right now, they had a product line which was only using wood to make acoustic tiles. And last year only, they have now moved 100% to cork tiles. And they only are doing all the acoustic products. So whether it is baffle ceilings or 2x2 perforated tiles, basic partitions, everything is being done with this raw material, which is natural, sustainable. Again, you're not creating cork waste. It has to be used in wine bottles. So it's it's a product that is just available in every market, and you collect it from the wineries or from people in a reverse logistics fashion, which is something this organization is trying to build. So they're creating small micro entrepreneurs actually, who are going to collect this waste of cork waste as well as wine bottles, let the wine bottles go into recycling, and give this cork waste back to Spinebeck, who then compress, mash them, and convert them into different shaped tiles. And the second is a picture of a school in Gurgaon. So something that actually in a month's time, if possible, you can visit as a budding architect. It's called Heritage International School in Gurgaon, which is right now one of our clients. And what we are doing is we are doing the multi-purpose hall and library. And similar to these acoustic cocktails, we are doing the complete sealing of their MPH and library with our raw panels. So these are not painted like gypsum, but we're letting them exposed in their raw form because the architects wants the student to look at the material. Because this is a school which is international. They believe in experiential learning. And what better way to make a student learn about sustainability by making their own build space where they are being taught to act as a medium to understand sustainability. So that was the passion, that was the incentive for the architect to use our material and then pitch it to the client. And I keep mentioning architects so much, not because I'm doing a lecture here with architecture students, but because you really have the power to push a material into the market. And that's how the collaboration started with this firm. And this is a picture of a 3D image of what the final MPH would look like. So on the floor that you see are again our panels used in form of planks. The wall looks this orange and gray acoustic fabric, and at the back of this fabric is our panels that are used on 9 mm thin panels, and behind the 9 mm thin panels is a frame again made of a panel. So similar to stud wood framing that is done in Europe, we came up with an idea to not use GI, to not use steel, and use our own 30 mm thick panels, cut them into 75 mm thick strips, and make a frame, like a wooden bait-in frame, put the 9 mm panels, screw them on top of this frame, and then put the acoustic fabric on top of it. So that's how we're doing the acoustic walls. And the ceiling is actually again the raw exposed tiles. So these pictures, they also put together for a reason that the raw texture of cork tiles looks very similar to the raw texture of our basic panels. So the idea is that you can go global with a product like this. You're not limiting your aesthetics. You can reach out to any kind of customer as an architect. So you can pitch this to someone sitting in Gurgaon or someone sitting in Europe. There will be acceptance. There will be receptivity to it. So that's how the multi-purpose hall will look like. The complete wall, flooring, and the ceiling done in panels. As I speak, the work is happening at the site. Construction is going on. And hopefully by the end of April, we'll be handing over this site to the client, and they'll be able to start school post this COVID issue that is going on there. So this is again a picture of our panels, which is used for partitioning. So when we often think about partitioning, there are certain requirements. Your wall has to be waterproof, has to be fiber-proof. You're going to mount a TV. You're going to mount a lot of gadgets these days on your wall. So it has to meet those requirements as well. So we are not just saying that it's going to meet your aesthetic value. It's going to look great. So it's not just because it looks fancy, it looks different, you should pitch it. But it also has a lot of technical value, this straw, that can be utilized and exploited. So the three values that we see in this material, straw, is its acoustic, fire, and thermal properties. So acoustic, I already talked about it, that any kind of natural fiber, their structure, the organic structure is such that it has great value in absorbing sound. We have done proper analysis of it on softwares, neural softwares, and have gotten testing done from NPL, which is National Physical Laboratory in Delhi, for the NRC and the STC value of these panels. And a 2x2 plain tile made of this straw fiber versus an MDF has much better NRC value and as well as STC value. And secondly, it's thermal, which again comes from its natural logic that it is a great insulator. So in Europe, in 17th, 18th century, even in India for that matter, I think we all must have witnessed these old homes that were made of straw bale. So at that time, they didn't have the machines to compress it. but they still used this straw in loose form and made these thick 24-inch wall, which was far more insulated than a brick wall can be today. Even for that matter, in Ladakh, there are some places where people still compress straw bale and use that as the insulating lining in their walls because it has thermal mass as well as acts as an insulator. And thirdly, it's the fire benefit of this material, which is something that sounds counterintuitive because we see straw burning, but that is because it's being burnt in a loose fashion and there's oxygen available for combustion. But actually, straw has a very high silica content, which is a deterrent when you're trying to convert waste to energy. So there are a lot of exercise and experiment done on converting straw to fuel. And the reason that none of these factories have been able to viably do that at a scale is because of the high silica content in the straw that limits its calorific value. But in our case, when we are thinking about built space, this same silica is a great positive and a great plus for us because it makes it fireproof, which then helps us to achieve the right fire rating. So according to the National Building Code, you must be aware that most of the industrial and specialized spaces like schools and hospitals have to have a 2R plus fire rating for most of the materials, walls and ceilings. And our material has been able to achieve 3R fire rating in warehouses. We have done warehouse for DHL, Iron Mountain, which is again an American customer, where they have achieved in their warehouses a fire NOC of 3+R versus 2R when they were using traditional current other competitive materials that are available in the market. So this is again reimagining our walls. This is a structure that was done 2 months back in Jalandhar for a client called Bachelor Hospital, and they're going to use this space for OPD. And actually right now they've converted it into a COVID hospital, this extension of their whole space. And they're looking after COVID patients in this building where the ceilings and the partitions and as well as the doors. So we have used 30 mm of our panels to make fireproof doors to make this complete 5,000 square feet of build space. So that is the value that you can see at a market size. That, okay, if you're an architect, why should you care about using this product? So I showed you that you can use it for different textures. There is endless possibility in terms of aesthetics. You can do any kind of finishes. It also meets your minimum checklist of technical requirements. So that's how you think about as an architect. Now, as an organization who's manufacturing this material, why does it matter to us? It matters to us because we believe that this innovation of biomaterial is an enabler. Because if you look at the complete value chain of this material, when no one needs it, it's sitting idle at a land, you burn it, it creates carbon dioxide emission. If you do not burn it and you let it decompose by throwing water at it, it's still going to emit methane, which is again a greenhouse gas. So no matter what kind of in situ management is happening with this straw, by burning or letting it decompose, there is some amount of greenhouse gas being emitted. So a green way of addressing this straw will be to have an ex situ management, which is where you completely take it out from the land, you don't leave it there to decompose or being burned, and then turn it into a value-added product where that carbon dioxide, which otherwise would have been released, is locked and sequestrated. So that's where we see value, that the entire supply chain of this raw material can be revisioned. Now, when you're talking about the value chain, there have to be different stakeholders. Right now, when we collect our raw material, which is paddy, straw, and sugarcane waste, we tie up with FPOs. We tie up individually with farmers at times, who then go and hire a baler machine, take it on rent, pay for it, convert the straw into bale. We pay them a price for that bale, take it to a factory where people are working, converting the straw bale into a high-density engineered panel. And then those panels get used into different projects by architects and designers at this point of time. Going forward, we'll be keeping it in retail in the traditional fashion that most of the raw material is kept, where you can go as a carpenter or an end user and buy this sheet like you would buy an MDF or a ply sheet. So in the entire value chain, there are multiple points where you're creating value, where you're creating income, where you're creating additional livelihood, and you are adding value. So now when it comes to value, and you're thinking about it from the business point of view, you have to see how much more value you can provide, because it's now not just about environment. it's also about the economical value that you can get out of this product, because otherwise you're not going to get your investors, you're not going to get people to put in the money. So I'll use a very simple example. When you convert straw into briquette, which is another alternative usage, you are paying 2 rupees to buy straw, converted into briquette, which is sold for 5 rupees per kg. In our case, we buy this straw for 2 rupees per kg as well. Now, a square feet of a panel requires 5 kg of straw. That means I'm utilizing 10 kg of straw. That means I've spent 20 rupees as my raw material price. And now this 20 rupees of like this square feet of panel, when it is compressed and made into a water and a fireproof panel, it is sold for 70 rupees per square feet. So from 20 rupees per square feet to 70, there's a 3 to 4 times multiplier that is there. And in that case, it was 2 to 5 rupees. So that's the value that we see from going from 2 to 5, you're doing 10 to 70. And that is the multiplier that really makes any problem or a solution to be replicated at scale. Because when I tell this number to my investor, he doesn't care who uses it. He doesn't care if it is an architect, it is a school, it is a government, it is an NGO, because every time this material is being used, the multiplier is exponential. He can show the value to the stakeholders in terms of farmers, income, livelihood, and he can see the multiplier for himself as well in terms of the monetary return. So organic waste can have a much bigger multiplier effect when it is converted into construction products than when it's converted to energy or other alternative usages that it has. So we as an industry have the biggest potential to make an impact on this raw material than any other, both from an environment and an economic viability standpoint as well. And this is a case study that I wanted to share with you, which I can also share a link of later, which was done in Milan 4 years back by an organization called Arup. So Arup is one of the leading design firms out there globally, based out of Sweden. And what they did is that they did a research which is called BioLoop, where they essentially say that 30 to 40% of the global building material, no matter what the building material is, you're using it for cladding, for tiles, for ceiling, flooring, doors, some of the other usage in our build space of a material can be substituted with a biomaterial. 40% of global material requirement can be substituted by a biomaterial. And then they went about doing a research on more than 10 different sources of such fibers. And then they went and did a practical case study in a city called Milan in Italy, where they said that if this is done, this is the amount of value that can be generated for the government, for the stakeholders, for the industry. And then the government of Milan, the municipality of Milan actually took it up and they created a whole value chain around it. So what they say is that in Milan, there are basically 3 main sources of raw material when it comes to waste. Cereal, so wheat straw is their main source of straw instead of paddy. And there's a lot of fruits and vegetables that is grown there. So for example, orange and banana. And the harvesting index of this cereal crop is 0.5, which means if you have 1 ton of crop grown, there's going to be half a ton of straw produced as well as a byproduct. And in the city of Milan, there is more than 215,000 ton of maize waste that is generated, rice and wheat. That means half of that is essentially a waste that has no value, that is sitting idle, and this is a lot of untapped potential. Now they went ahead and said to the government and to the architects and the design fraternity there that even if you use 10% of this waste and convert it into different applications, in this case they converted it into a cladding material and a drywall material, that if only even 10% of this is converted and diverted to the construction space, you are creating 8 million square meter amount of boards that can be used for cladding in Milan. Just one city, 8 million square meter by using 10%, which means that often when people say that you're addressing a problem where your raw material is so risky, is so tricky, my answer is that it is risky, but it is so abundantly available. In India, we are burning every year 94 million metric ton of straw. My one factory every year, even if I run it at 100% production capacity, doesn't need more than 1 lakh metric ton of straw. which means that I can set up 96 factories before I really run out of this raw material, which is practically not possible. You're not going to go set up 96 factories. So even with few factories, you have a business that is making a lot of money and a lot of impact without being worried about this raw material. And even if then the question is that, okay, it's a risky raw material. What if, there's not a proper rain, there's seasonal variation. Then this study again tells us that you can always play with different raw material, which is something we have already been doing from the start. So we are never dependent on one raw material. We work with two right now. We are raising investment and we're going to start doing R&D on other sources of waste, such as coconut, lantana, which is a forest waste, as well as wheat. So our idea is that every year we'll at least do R&D on one source of fiber, compress it, do a lot of trial and errors with it, and find what is a potential best case use of it. Maybe something is a light fiber, doesn't compress well, and it is loose. Well, that's okay. You can use it as an acoustic tile. If some fiber is hard and achieves a higher density, then you can use it as a weatherproof material. So there's a lot of value to each one of these fibers. You just have to figure out where does it fit in the complete build space that you're working with. But this study in Milan showed that there's so much potential with just one raw material. In this case, they were working with maize here. And how much of that can be used to make a city completely go green in terms of its cladding application. And now imagine they only have 215 ton of maize waste. In India, we have 96 million ton of waste that is available. The potential is huge. And then there's another example of stalks and leaves. So often when we're talking about organic waste, we're talking about these hardcore fiber, but actually there are such simple things as natural flowers and leaves that wither and they fall down and they are decomposed. You can actually set up a very small pressing line and compress these and make very interesting, natural, aesthetic, appealing veneer. So there's an organization based out of Portugal again, who makes 2 mm thick veneer out of natural flower and leaves. So the interesting thing is that when you go on their website, they have different veneer every season because that is based on the flowers that they are getting. So no two people will actually get the same veneer. Every sheet is pressed independently. There's a different mix of flowers and leaves going in. So you have a very unique veneer every time to work with as an architect and as a designer and offer that unique unique aesthetic to your customer as well. The way we go and pay such high money for handmade garments and fabric and sarees because we're like, no one else has this. This is unique. You can actually create such unique building materials out of such natural waste and make much more value addition. You probably can ask a 10 times price for it than 4 times in our case, and people would be willing to pay for something like this. And this is a slide which shows the scale. So I talked about a problem. You see a problem, you think of a solution, you then go ahead and you do a minimum viable product, which is you test that hypothesis of yours for the solution. And once you have a bit of a confidence, you go ahead and do it at a scale. Now at the scale, you have to have both of your things at scale. One is market and one is the raw material. So this is a slide that shows the raw material at scale. This is a legend of different fibers that are out there. So sugarcane, cellulose, maize, peanut, banana, potato, or hemp, wheat, pineapple, rice. So these are most common grown fibers globally in most continents in the world. And the map shows that which one is present where. That means besides Antarctica, literally every continent can use biomaterial. There's at least one of this fiber available in every country to be utilized and substitute a traditional building material that on the contrary is using more carbon dioxide to be manufactured or releasing far more when it is being utilized. But there is potential to do it in almost every geography. So then your idea immediately doesn't remain local. It becomes a global opportunity. So when you go and pitch this opportunity, the potential is endless. And you can expand to multiple countries, keep getting different certifications. So that's something, again, we are planning to do. We have got all our testing done by Indian standards. Going forward, we're going to get it done by the European standards, ASTM standards, the same parameters that you have, so that we can export it. And actually export it only for a while. So I will, because again, when we're talking about sustainability, you do not want to export this material for far too long. I had no other option but to import it to India to test it before we start locally manufacturing. But when we export a material, you're defeating the core value of sustainability because there's emission during transport. And this map shows that if I could prove the model of using paddy straw and sugarcane waste in India, then I can just go to Southeast Asia and pitch to a local player in Southeast, let's say in Vietnam or Thailand, convince him, set up a factory in partnership, and start utilizing the local paddy waste that is available in Thailand to be utilized and consumed by Thailand itself. And then when you expand to another country, you repeat that model. So the overall USP of what we're doing is not just the product, but it is also the supply chain of it. We want to create small factories, decentralized factories, not one big factory that serves all of India, but 4 different factories in 4 different geographies, so that the raw material is as local as possible. So its commute also doesn't generate a lot of carbon footprint, and a lot of multiple smaller communities can be affected. And also, you are de-risking your dependence on one geography and raw material. If today my complete source of paddy waste is coming from one district in Punjab, and for some reason you get into an issue with the farmers or the district, for some reason your supply chain is blocked, and then you cannot make your product. But when you have decentralized manufacturing, you're not dependent on one factory, you have multiple sources. You also don't have to store it for too long. So that's the biggest challenge working with a material like this on a manufacturing end, is that you're only going to get paddy once a year, similar with wheat and sugarcane. So when you're working with multiple sources, you don't have to store it for far too long. So if I need 10 acres of land to store an annual requirement of my straw, I only need 2 acres now because I'm playing with 2 fibers. And the more we keep adding fibers, we can reduce our dependence and our capex to keep setting up these warehouses, which leads to a asset-light business model, which is again something that investors love to put money into, because no one wants to put in a lot of investment in hardcore machineries and capex and then wait for the return. So here you are pitching a light asset model. You are partnering with people who might have the land, set up the machinery together, start manufacturing this material, and then as a company, as Strawcture, we go out and we brand it under our name and we sell it to architects, designers, end users. So that's how the whole business model comes together, or what we do at Strawcture. So you have to think long term. You can't go in thinking short term with a circular economy approach, because it starts at a very fundamental level as to how the product is made, how it's going to be consumed, how do you keep extracting it in a sustainable fashion when you scale up, which even if you're not doing right now, you have to plan for it today and put that as part of your business model. And finally, when that material is consumed, how do you take it back? So usually when we talk about sustainability, people just talk about how a raw material is sustainable. But if you look at the complete life cycle of a product, it's 100% sustainable only when it can be circular. So again, when the factories are decentralized, let's say there's a factory in Kolkata that is serving the Northeast and the East India. Now where then the raw panels are being used for furniture, you have better opportunity and less scale to do reverse logistics of this panel or this furniture back to your factory to repurpose it. But if you only have one big factory sitting in Punjab and you're sending the raw material, the raw sheets or the panels to Hyderabad, it's practically not possible at scale to say that every time I can take my material back, which means you are not closing the loop. It's easy to say, it's easy to commit, but when you're genuinely committed to the idea, you have to think about all of this aspect very early on, even before it has happened. So a person who's buying this panel from me today to make a furniture might call me 20 years later saying, I don't need this table anymore. But I need to think about the whole logistics of how I'll take it back from him today, so that when it occurs, we are in a position to build the infrastructure for it. So that's the challenge, and that's the exciting prospect of circular economy based business models, whether for construction or any industry, that you have to think at a design level, everything before you even start doing it at scale. And lastly, this is a slide which I just think makes a lot of sense to the audience that I'm talking to, that if you really want to make an ecological impact of any product out there in the market, 80% of all of that thinking has to happen at the design level. Whether it is manufacturing an iPhone, whether it is manufacturing a furniture, or it is building a house, 80% of all your decision at the design phase really decides how green, how environmentally conscious the product and its life cycle is going to be. And so as architects and designers, you have that vantage point to decide that 80% before you build a building, before you build a school, a hotel, or a hospital. And if you make that conscious choice now, then people in the rest of the value chain as stakeholders will have to follow the suit. If you define a product that is green and you convince your customer, that customer is going to use that material. But if you do not think of it then it's going to be a building at the end of the day and it will serve its purpose, but it's not going to create the impact that it can create. So this was mostly me just saying that you are in a much bigger decision-making position than I or other people in the as stakeholders are in the whole system. And so if you make yourself more aware at this age as students, as last year students of architecture about different products that are out there, if you're interested, I can also send a lot of links of different building materials, a website that only has a directory of material resource of all kind globally that are sustainable, made out of biomaterial, so that you can expand your vision and your imagination. And when you're designing, when you're finally out there as a professional designing any space, you can always reflect for a minute and think that maybe I could build this with a biomaterial than a regular material, and give your client the building, but there's so much more impact along with it that you can offer. So I'm gonna actually stop sharing my screen, and you can now we can have a conversation. So you can ask me now anything technical, how we did it, what's the price, how do you sell it, all those logistical questions. But this was the story as to why we do it and how we do it.
Thank you, Shriti. That was very insightful. I think very few people think of the afterlife of the project once it's out from their market. But yes, that's very, very thoughtful, and really so much of energy and consciousness has to be built into the society to take cognizance of that. So I have with me T.S. Ravichandran, and I think few questions will be, and also we have Gaurav. So Gaurav along with us. So we'll represent our students, and a few questions we can pose from their end as well.
Hi, Shriti. This was, this was, you enlightened us on this beautiful topic about recycling waste and making waste, a gold out of waste. However, if you could go to your penultimate slide, which says this thing is endless. What was the slide titled as? Which is endless.
Nature is an endless source.
Endless, yeah. So what I figured out from that slide is that India, out of the 18 or rather 12 building products that you had enlisted in the legend, India had perhaps around 8 or 9 of them.
Sure.
Right? That's somewhere between 2/3 to 3/4.
Yeah.
Right?
Yeah.
And hemp is used as a building block, right? Which we use in our buildings, in our designs. However, if you could tell us what are the products that you have just about talked can be converted into building blocks. We can talk. You've shown us examples and you've demonstrated how it could be used as internal partitions. But however it comes to the building envelope, we will require something which is a high density, which is weather resistant, and a low density, which is, as you rightly said, which is acoustically more beneficial to be used. So is there something that you have in mind or plan to do where you can fuse both the products together, both the characteristics together,
right?
options for external wall and as well as internal face for providing insulation or acoustical insulation. So I mean, and if it could be compressed in in say 100 mm or something like that, like a veneer, a veneer. And the only advantage, the maximum advantage that it would give to the customer is that it will increase his carpet area. And carpet area by not just 2 or 3%, by a good 25%. Right? Sir, I could actually compress the building footprint in a manner and provide him more green space outside. That could be possible. I know the customer will always go for the former because over here they gravitate towards bada kamra chahiye rather than so that way. If you could let us know, if I would be very interested in staying connected with you and try and utilize your products on my projects. I be a visiting faculty here. I teach building construction. I have always teamed up with Tanaya and Colonel Malik for such purpose. So that would be my question. And if
sure, definitely, definitely. So that is something. So we do a lot of work in the rural infrastructure space as well. So we work with foundations like Selco and IKEA Foundation, and we've built schools, slums, childcare centers, where we have realized, as you rightly said, that often there's not a lot of scope of interior partition because these are low-income families. All they can afford is just the bigger 4 external walls. So you have to think about that envelope more than the interior space. And so we are doing R&D on modular walls, where there's going to be 12 mm cladding, kind of a high-density weatherproof panel made of this waste. And then the interior core would be a light density, like a 500 kg per cubic meter core. So you get the acoustics, thermal insulation, and you get something that can be plastered upon, that can, deal with the extreme weather conditions that are out there, and in a form that is tongue and groove. So it has that male-female joint, and it could be brought and put in. So we did something on this line in Bihar recently. So we built a portable childcare center in Muzaffarpur, which is a flood-prone region. And there we built it for the government in collaboration with Selco. And now we are working with ICDS, which is the Child Development Service organization, the government body, to implement that in 14 to 15 districts in Bihar, which are flood prone. So the idea is that it's portable. When there's flood, you can move this structure and convert it into a shelter. And when, it's normal condition, it can be used as because every time there's disaster, when you lose buildings, you lose infrastructure, there's a cost attached to it. So if you're investing so much money to build spaces, if it's portable, that could, there's added value to it. You can increase its life cycle in such disaster-prone regions as well. So we are working on that for them, and then we recently have raised funding as well from an institute that works in collaboration with Habitat for Humanity. So we are also looking to scale up this modular wall that I talked about with such organizations that do housing at scale, where they need something fast, modular, and more so for the outer envelope than the interior.
Yes. And when you talked about the cyclic economy,
yes.
And so is this technology of yours disseminated amongst the beneficiaries so that they could build it like an IKEA model or something like that, rather than, depending upon your resources to go and reposition that or at some other place. I'm coming back to where I was associated with development alternatives.
Okay. For DA, yes.
I was with DA more than 25 years ago. So worked in a couple of places, especially in the rural India, where we did a lot of hands-on job with straw and plaster, and how to mud plaster bear more longevity on that mud plaster and all that stuff. So that's where I'm coming to. You see, when it comes to recycling, waste. Many a times this needs to be demolished and then moved on. I mean, you just need to move on. So when it comes to replanning this thing, so are you, I mean, is your organization, I'm sure, will be offering dissemination of that technology and transferring that technology amongst the beneficiaries, and so that they can carry their work forward and not depend upon you.
Oh, definitely. And that's yeah, definitely. So it's not about having a decentralized manufacturing, but also a decentralized way of constructing it. So often, initially, we started building, our whole team will go and build. And often people's biggest concern as an end user is that, okay, you're putting the electric wiring behind this wall panel that I'm seeing for the first time. What if I have a short circuit? Are you going to send the electrician? But that's not the solution. You cannot scale this way. So now we have reached to a point where we only send one person from our team, and then everybody locally builds it and they learn. And going forward, we don't even want that one person to go, but to come up with a very comprehensive instruction manual, a lot of instructional videos, where you just have to send the material, and the local mason who has worked with ply could work with this with as much seamlessness, same tools, same cutting machine, bead, hardware, and so there's no upskilling required. I mean, it's great if you could pay them more, but if there's too much of upskilling to be done in terms of capacity building, then it becomes a deterrent to scale newer technologies.
Thank you so much. Thank you.
Thank you so much.
I will be glad to stay connected, and
sure,
I will. I'll obtain your numbers from your contact details from Tanaya at some point.
Definitely.
Thank you so much. Have a good afternoon. Have a pleasant evening.
Thank you.
Also, we have Gaurav Mani with us, and I think he has been using your product.
Thank you. So as I was saying, it's architects like Gaurav who push and try to promote products that we're working behind.
Today I understood your product. It was really exciting, Shriti. Hope you can hear me.
Yes, I can hear you. Gaurav. Yes.
So it's really.
So Gaurav, what has been your challenges?
There is not really much, and it is really happening to see people like Shriti from the civil engineering background going into innovation and developing new products and coming up with such innovative solutions and going to the last bit of detail into it, what will happen, and making it sustainable in true sense, sustainable in terms of the carbon footprint and sustainable in terms of making the business sustainable.
Right. That's equally important. Yeah.
Commercially also sustainable. So that is the biggest challenge which we face, that products are there, but then the commercial viability is not there. The chain is not thought out. So your level of detailing into your venture is exceptional. And I think all our students also going the way forward will definitely be more keen to understand the products, and as you rightly put it, they will have that opportunity to use and specify the product. So have a great future with this product.
Thank you.
We wish you all the best and you prosper and are able to carry this model further across to the masses, and great work which you are doing, Shriti.
Thank you. Thanks, Gaurav. Thanks once again.
So thank you, Gaurav. So we have two questions here. I'm trying to get them connected as well if they can join. But in the meantime, I'll just read the question out so that we can discuss. So a question from Shivansh is that these raw material, that be it straw or that you're talking about, is biodegradable. That is, it will degrade in a certain frame of time. How do you, if you do, stop or slow down this process while manufacturing these products? So yes, it's something about sustaining or keeping the product in a certain state while it is being manufactured.
Right.
So if you want to take that.
Sure, definitely. Thanks, Shivnash, for that question. So as I said, so the way this material is manufactured is very similar in fashion to engineered wood products, so ply and MDF. So we make 3 layers of this straw, mix it with resin. 94% is straw, 6% is resin, which is a non-formaldehyde resin in our case. And then they are compressed at a certain pressure and temperature. The temperature is usually above 200 degrees centigrade in our case. And then 3 layers of this straw and resin is compressed into sheets. So it's similar to ply, where you have 16 or 12 layers of veneer, thin sheets. In here we have 3 layers, and they're compressed into making these thick panels starting from 9 to 40 mm. So when you're mixing that resin, because it's binded with the straw, will stop it from degrading on its own if it is exposed to the weather and the air condition. So the biodegradation will only happen, as I mentioned earlier, when this material is taken back. So there has to be reverse logistics for it. But at that level, we can biodegrade it. And then it will take, so you break the bond again by using pressure on this resin and panel. And in 120 days post that process, this material can be 100% biodegradable, which has been done, which has been tested. And we are also going ahead and getting a LCA, which is a life cycle assessment test done on it from Seabrai Roorkee, to then have an exact number as to how many. So we have done R&D and it shows 120 days, but getting it from them to say, okay, so if 20 years later you still give me back this material, in another 4 months it can degrade. So that's how we do it. Yeah.
Yeah. So there is also Shrisha Shetty. She's thank you. So hi Shriti, quite an insightful webinar. Glad I came across the link. So well, I just wanted to know your views if this processed product could also be used as slabs as well, and if yes, how would they be possible? As there are ways more load than a slab takes. Yeah.
Okay, so that's a great question. So we have used this material as a flooring material in industrial warehouses. So in warehouses, usually the go-to way is you make your steel frame, your mezzanine, and then on top of that so for now we have only used it for mezzanine, where traditionally you have a steel frame, you put a deck sheet and you pour your 3 or 4 inch concrete. Versus that, what we have pitched and done is on that steel frame, instead of pouring concrete, you can either use this panel along with deck sheet or without a deck sheet. If you're using it with deck sheet, you can achieve a UDL of up to 1000 kg per square meter. And if you're using it without a deck sheet, then a UDL of 500 kg per square meter, which is a number that is decent to be used for commercial and residential application. So to answer your question, so if you're building a 2-story or a 3-story building, of course, the ground would be civil because of the foundation. But the multiple floors that you do in your building, you can use a steel frame and these panels in combination to build your floor, like a composite flooring, and eliminate the usage of concrete. And this is something we have done for warehouses. So we have done a project in Bangalore for a brand called Arvind, which if you're aware of is the main brand that manufactures jeans for almost every brand that is out there. So we have gone ahead and done 1 lakh square feet of their flooring, of the mezzanine floor in the warehouse using the 25 mm thick panels of ours, and they completely did not use concrete for that mezzanine.
Yes, so that's quite a newer application which gypsum can't hold for.
Yes, yeah, because it cannot take that much load. Yeah.
So we also have one question on the economic side of it. So Nina has asked, please do share a cost comparative analysis per square foot with comparable material. So just an idea. It's not.
Sure, no, definitely no. I'm always very transparent because unless that is one factor that also has to be taken into equal consideration. So if you compare it with a waterproof ply, so if you have an 18 mm waterproof, fireproof ply, the cost of that is around 100 rupees per square feet, and the cost for us is 75 rupees per square feet. So it's 25% cheaper. Just give me 1 sec. Can I hold for a minute?
Yeah. Yes. So from the audience, students and participants, if you can use the Q&A, or even on the chat box, you can write in question. This is a good opportunity that you have when she is here in person, or not in person, virtually connected with us, and she can answer your questions.
We would have loved her to have in person.
Yes. I was.
Yeah, I'm so sorry. Yeah. So with ply, it's 25% cheaper, as I was saying. Similarly, if you compare it with a drywall partition, so usually when you're doing a drywall partition, the way to do is you use two 12 gypsum on both sides, each skin, and then you have a 50 or a 75 thick GI framing. So the cost of that is around 150 rupees per square feet, which involves the panel framing and its installation. In our case, our panels are 10% expensive than gypsum, but the value is that you do not need two sheets because it has more fire rating and water resistant capacity than gypsum. With just one 12 sheet and the frame, you achieve much better functional parameters. So there our cost is actually 130 rupees per square feet. So the clients of ours that have used this versus gypsum in the drywall market, they've achieved the cost, competitiveness and more than 2R plus fire rating and waterproof capability, which is not achievable with the comparative material. So you get that value for sure. That is there. Yeah. And we're definitely working to, with scale to bring it much lower, the cost that is already there. But yes, so the answer is that we're not exponentially or exorbitantly expensive than any of the direct material that we're competing with, because we're always conscious that unless it is competitive, you can never scale. And if there's no scale, then there's no value of the impact that we were talking about that we want to achieve.
Yeah. So just a question out of curiosity, when this is achievable and it's doable, you have done it also. Still, we are facing so much of issues of stubble burning, and the whole winters for northern India is quite gruesome. What is that one thing that the farmers are still holding back, or they find this alternative? Even the government has given policies of buying or giving them incentive of buying. Yes. But still they are not heeding into. Is it awareness, or what challenges have you?
So the problem that I see is of scale. So as I said, one of a factory can utilize 1 lakh metric ton of the straw, and there's around 20 million metric ton of that burnt in Punjab. So the potential is that, as I said, so we are also like that European partner that I mentioned about, from whom I learned. We do not plan to patent it necessarily, this technology, because we do want it to be decentralized. We want more players to come up and do this. So recently, a week back, I was in Chandigarh and we had a meeting with the Department of Science and Technology and the Principal Secretary of Agriculture, where we were pitching to them that we would like to, with the government in collaboration, set up a pilot factory, a small factory, not a very big one, and then get all the stakeholders together where we tell the farmers that they don't have to worry. The government is going to take care of sourcing the straw from them. There's an entity like us that will manufacture it. There'll be a proper channel of being paid at times consistently. And then using that case study, then show the scalability and parallelly also work with the government to create market for this. So for instance, right now, if for the government itself, like they could be one of the best customers that are out there. So once the government itself starts utilizing more of this material, there's more acceptance. So that is what we're trying to do. So we're right now in talks with the government in Punjab and Northeast, where we're trying to create an ecosystem where all of these partners come together, where we find a local manufacturer. We have a financer who could invest in the machinery with them, set up a plant. We give all the technical know-how. Of course, there's a secret sauce, so it doesn't just, like we have no defensibility, but not like just go and do patent. And then scale it up, because we are very confident that creating demand for this is not a problem. This product, I was recently in Bangalore and we are accelerated by Brigade Reap, which is one of the biggest real estate company down there. And they made us meet more than 25 architects who are top 20 architects in Bangalore. And not a single one of them had a negative response to this after looking at the sample. And all of them are interested to use it. The challenge for us is to parallelly streamline the supply at a scale, because once you push this in the market and then somehow someone needs a lot of million square feet of this material, in 2 months, and then if you don't have so many small factories, you will fall flat. So we are right now, so the funding that we are trying to raise, we are actually investing that to create that supply chain at scale. And once that is in place, then we don't even have to worry about fighting ply. So then when I become 40% cheaper than ply, then I don't have to worry of a carpenter or a builder questioning its usage. And the farmers at scale can send their straw, and then even if you're a farmer who's apprehensive, you're going to see a lot of others doing it. So, and there's a proper, how do I say it, like infrastructure for it. Because right now, if I'm a business person, if I collect all my year-long paddy straw from the farmers, I need to have more than 10 acre of storage. That is a huge cost. But when we partner with governments and another academic institute, and they start giving us storage space and give us straw as a service, which is a model we are trying to explore in Punjab, that if straw can become a service where I have a setup, I tell them I need it for 3 months, this quantity, this variety, this amount of moisture content, and there's another player in that ecosystem who is providing that service, then the farmer is not worried. He knows that there are people coming to them asking for this product because they are offering it as a service to someone else. There's value attached to it, and then they will not question it. But right now, they still have to see more value to it to do it at scale, to tell themselves like 2 weeks before harvest, okay, I'm going to be ready to give this material away when someone approaches me. And even if someone is not approaching me, I will invest in a baler machine on a rental basis, store this, because a month or two later, there are other businesses that want this. So it's like a chicken and egg problem. You have to create the market for the product and parallelly create the supply chain for the raw material as well, which is something we're trying to do with multiple partners that we have.
So Shivansha has one more question here. So are any VOCs involved this entire process and post curing?
No, so there is no VOC involved, Shivnas, and actually that is something that is one of our USP. So recently we were talking to a client in Bangalore who said that now, thanks to COVID, like I say thanks because I hope there are some silver lining because of COVID, that people are now very concerned about the air quality. They want to check the VOC emission, similarly how they check the moisture, quality in the room. So we have no VOC emission, and we are actually going forward and utilizing. We are doing R&D with a different resin right now for paddy, where instead of E1, we're actually going to go ahead and get an E0 certification, where there'll be not only just formaldehyde, but none other emissions happening that are dangerous and toxic, so that we can then create an export market for this in Europe.
So yes, Shriti, that was great. And I think if we were here in person, the questions would have been much
Oh
more
yeah, definitely. And I
detailed.
could have got the samples for them to see.
Yeah. Yes. So definitely we'll love to host you to our campus once we are back to normalcy. And thank you for this insightful lecture and sharing your thoughts. I'm sure the students are inspired, and lots of, I think it opens the horizon for them and to reach out if they passionately feel about any topic.
Definitely, yes. For sure.
Thank you, participants, for joining in today for this lecture. Thank you, Gaurav sir and Ravi. So it was nice having you, and also Shruti. Thank you for taking the time out and interacting with us.
Thank you. Thank you so much. Bye. Take care.
You,
they have my email address, so if they need, they can directly reach out.
Sure, I'll share it with my class and everyone here.
Definitely. Okay. Thank you. Thanks.
Thank you.
Thanks.
Bye. So we close.